So we are going to present our product, and we're going to do it day by day. The first day we went to exploring the material and its possibilities, you know, just forming and cutting and doing things like that. We did some modular things, trying to put the things together in different ways. We were a little stuck with the triangular thing. You'll see that. We were a little inspired by the Lego thing. Does everybody know what the Lego is?
Yes.
So we were a little inspired by this, and we tried to connect the box with the lids, and then started working with the machines. Okay. So it's a little small pictures, but you can see the first picture. We tried to just put the three bottles together with the tape and just see how it would function. We tried to use some acrylic parts and trying to use aluminum instead of the tape thing. And you can see here that we tried the aluminum and the pop needle. The things together, you know, the knitting. Try to drill some holes in the acrylic parts to make the pieces stuck better together. Then we came to this conclusion that we make the parts stick together like this. Should we make it go down?
Yeah.
We try to connect the pieces with only using plastic bottles, so you can see when it comes around. I don't know if there's anything more that they want.
Can you take a look at that so that you are close to this position? Okay?
Yeah, as you can see at the bottles, there's that white part. It's think that we have to melt the bottles and then make it. So it should not be that material is made of there, but the idea that that part is working, that should be the melting parts. Yeah, we made some testings to like how do you say connect them. And you can see a little part in the middle. We had to put something in there because otherwise the bottle would not connect, as you can see here. You connect like this, and it has not any force to do like this, so we had to make some parts, the socket in the middle. We used testing several ways to do that with springs and elastic and all that stuff, but we find a nice way to do it, to take two bottles and cut them and then melt them together, so you have like a bottle with a knot in the end. You have a thread at both ends, and you can use them to the white part.
Well, the thing is, when we decided we wanted to do something triangular and modular that would have like a structured characteristic, we started to think about this piece, like what would be better for the bottles to be like really rigid. So we started with 3 rectangular parts, like in the picture you can see it. Can you please go back? In here, no. We have like 3 overlaid rectangulars, and then we decided that for the piece to be like more structured, it would be better to be only one piece. So we designed like this first one in PS, like white PS, because it would be flexible, but at the same time it would be a little rigid. Then when this started to happen, we started to figuring out what to do, and the connector was all about this. Like, as you all know, the PET bottle, they don't stick together, like they don't glue. So you have to work with heating and then changing the size of them, so to put them, shrinking, to put them together. So this genius guy did this to put between the bottles. And we have a little sketch that shows that. You can please go on now. Oh, yeah, we're not sticking to the schedule here. Anyway.
Okay. So that's the...
Yeah, that's the thing, like that's the connector. We took like the top parts of both bottles and with heat made like a thing like this. Another thing we started to think about was to use only PET bottles as the material, as the main material. So this, in an ideal world, should be made by PET bottle. And we started to try flattening the PET bottle. So we tried to make like a sheet out of it, only with a giant blow dryer first, but it was not a successful thing to do, obviously. Then we started putting it in the oven, so it would be like more tension, but it had to be like only the smooth part of the bottle, like this. Couldn't be wavy or had any texture on it. And that was hard to find and hard to fit, like to stick to the table. We would put in the oven. So we tried a lot. And you guys probably heard the little drum we made sometimes. And there are some pictures of the process of doing it. Like, next one, please. I'm ruining it, but sorry. So this is it, like the bottle, rounded bottle, and we made like a frame out of wood, stapled it, and then put it in the oven, and it became like this. After this, with the help of the lady we call the laser lady machine, like the laser machine, she helped us do this. But obviously, one sheet, it's not enough to hold like anything. So to do it, we'd have to use like 5 or more layers of PET. But it was nice to figure out we can do it. Like you can heat it and flatten it and make it more tensioned than it is when being a bottle. So that's the laser machine working on the flattened plastic. So in the middle of all of this, we had the cardboard experience, and it was really nice because it showed us that we wanted to work with a modular thing. So we got stuck to this idea of the Lego, the puzzle thing. And the mic is all about Paula's speech, and acai because the guys tasted it. That's me. So this was like some things we are trying to do with the modular thing. This is all made by the same modular rectangular thing we built. And then we were trying to change the user's view of the world. It's another thing. Like it has not, I don't know what I'm saying. It has no, I've lost my ability to speak English. Okay, so returning to the bottle exercise, like on day 4, we started to work on different thickness, plastic with different thickness. So this is a possibility we tried, but it was not like the best one, because the bottles, they can be pretty strong. So this one, it will be like a midterm between the PS and this orange one, but it was not strong enough. So we continued doing this, and then we made souvenirs and necklaces. And then, like this morning, we had the brilliant idea of putting water inside. And then the bottle became like a rigid thing. And the idea of using like some kind of angulation with the bottles In this case, it's not explored because we did like this other kind of ring here, but it was the only way we could make it like 90% stable. Like you can sit here. We have tried putting Bruno on it and it works. But this one, like where we tried to put the bottles separately, like it doesn't fit. We would have to do more mathematics. Like the shape is not right yet. And this is another possibility of using it, but as these bottles are not filled with water, they're not as strong as these one, like this and this, and it's pretty stable, but not like that stable. When the big guy here tried to like really pressure it, you'll see it's kind of good, not that good. But the thing we liked about the whole thing is that this is not a finished product. It's not a product. It's like something that could go on forever, because we could like decide to use only this kind of bottle, for example, and then study like this specific like circle, and then use this curve to put it here. Then it would fit perfectly. So it could be like this could go on forever. And that's the nice thing about it. Like if you use this kind of plastic, you have one result. Then if you use this one, you have another, and that's the good thing about it. You can do lots of experiments, and the whole cap bottle thing, it's another positive thing about it. So we did like these, we put like extra holes in here, like on the top of the table, so you could really do whatever you want. So even though this became a table and this became a chair or a stool, it wasn't like the main idea, but it's like Lego. You can kind of do the whatever way you want. And even with small bottles, and we have a torch in the middle of the process. Because this guy, he likes fire. And sometime in the way he wanted to do like a torch, the Olympics or something. And then we used, and this was nice because we were like melting the plastic, and this was the first experiment we had with the melting and shrinking the bottle, so it would stick, not glue, but stick to some other kind of material. So this was a good starter for the connectors. And I don't know.
Just that with these models, you know, the triangular thing, you have like endless possibilities with your building and Lego, where you can build whatever you want. If you just have the plastic bottles, even the small glasses when it has not been blown to a bottle yet, you know, the small. So if you just have like the lid and the top of a bottle thing, you can do like whatever you want with these things.
The yellow parts we're using like that is plastic now, but in the future, if we go to work with this, that's be Adriano was saying that you have a lot of bamboos in Brazil. We'll do this in bamboos.
Okay.
I'm just, it's not the shapes, but it's about the head. I don't know. Now it's green. First of all, thank you all for a great week. It was splendid. Now, on behalf of my group, I will do an introduction. This is our product. We're going to talk about how we got there during this slideshow. Yeah, can you press the button? During the week, we work with lots of methods and experiment lots of things. Especially, we work with flexibility the transparency of the material. We also work with the strength, joining, colors, and the threads, and gravity also. So those are like a list of some of the things we work on, the things we have been focusing on. So this is us working. First we work with that one. Fabiana, if you can show the video. We start working in small groups, so we're like working in 3 different projects, like in the start. So this is the thing you see Fabiana standing with, the ring, which is gonna continue on. We're gonna continue talking about that. In the middle, we work with the aluminium, connecting the bottles with the thread, and we're like thinking about how it's gonna spin if it's not attached completely, and playing with that. And then we also work with some attachment from the top. The next one.
Well, we decided to invest in this idea of the ring made by polycarbonate, and working with these strips with holes in it and attaching bottles, so that we have a circumference here, and we've attached the bottles here in these holes, alternating the holes where we put the bottles. And and we started doing some different structures of these strips. For example, we tried to do the structure that is similar to a DNA one. So twisting this ring, we could have this result. You can look on the screen. It can be stable itself, but if 2 people press it, on the opposite side, you can get a stable structure. Well, another possibility of dealing with this structure is, making a pile with a modular ring with the bottles outside the circumference, and we could make a great structure, pile them, and put in one on the top of the other. That's another possibility. Well,
in these photos, you can see we put in the mouth of the bottles at the holes and close them. We tried a lot of things. We chose this project because it's very simple, it's very close, and it's to make the holes, and there's a lot of possibilities here. You can just cross this, and you can make a lot of things. I think that is, it's a lot of possibilities. You can do things like that.
putting the bottles inside.
We like this material because of the flexibility. It's very good. So next. There's other examples that we did. So and so because we separated all the things we did, so we cannot show for you all the possibilities we can do with this. when was working with these bottles, we saw that there's too big, and it's always happening when we don't work. So we decided to work with the small ones, and that bottle. That bottle, you can see the small bottles, and we try to think in the other idea. We are searching for something that makes sense. We are looking for something that everybody could love it. I don't know. I think that now might be defined.
So here we start to choose a function, to create a functional product with the same principle that we used on the first day. These are some drawings of, we have the idea to create a lab. We have the first sketch of the product. We chose the same rings, polycarbonate rings that we made in the first day to structure the lamp. And between the rings we have some strips of the PET strips, make the connection, make the connection. Here we have some of the materials that we use. And here is our start. We start to work to construct the product. In the middle picture, we start to see how dimensions the lamp will take. We have to choose the measures.
We had to figure out how to join these rings in the end, since we're not using the bottle and the cap system any longer. So we tried to use the string to tie them together, and it worked fine for us. Then we also, we decided we wanted to make a lamp, so we had to somehow cover up the ball so we won't get blinded by the light. There are many possibilities of threading these rings. So we tried some different styles and different techniques before we decided on which one to use. Yeah, there's quite a lot of work in threading these rings, but it actually went fine. But it's a little hard controlling the strings, because they're bended, and we had a little trouble doing that. We had to use some weight, so we put on water bottles, and it was making the job a little easier, and it was finally taking shape, our lamp.
So as the final result that we had, we tried to turn on all the lights and taking them to a room. As I said, turn on the lights, and we had a proof of our work. So this is how it became the best. So now we see the final product and how it is today. So as Shane said, we try to apply the material to make it a functional lamp. So we put the lamp on the center, and we take them into a glass, and we turn on the lights, and so you can see the shadow casting into the walls, as you can see in the next slide. So it became more interesting in a functional way. Yeah, we still can try turning the lights on to see.
I got turned off. Very beautiful. Yes.
That's all. That's
Good afternoon. About the workshop, about the first day, we were told to work especially with PET bottles, PET plastic bottles, and the idea was to not, for example, cut the bottle or something like that. So we have to kind of explore the material on its original form. So we had the two principal characteristics from the bottle was empty or full. So and by the full water just contain the waters in, so we can drink or other stuff. Or the empty bottle where it can, for example, float all over the place. And or for example, with its where it has the bottle entrance, we can play something with for example, like with the wind or other stuff. So for example, if you blow the wind in some kind of angle, it can make some kind of noise, some sound like a flute. So at the first day we had two different ideas. The first idea we had, it was to create some kind of a sphere built with a lot of bottles, empty bottles, but we wanted to make all with the same kind of bottle, so we didn't have all the bottles we needed to. So we constructed, we did all we could make it. So it was kind of that idea, but by the purpose that we didn't finish it, we named it as octopus. So the idea was to float, and the other idea about the wind and sounds and other stuff, we made something that had the idea, for example, from the we had for the idea, for example, me and Rafael had at the first semester about the air machine, something that we were inspired about Bruno Munari, about their air machine, something that moves with the wind. So we had the idea of making a big some kind of metal wire and put a lot of bottles on it. In the idea and to move it, we put some kind of elastic rubber down there where we could spin it and actually work with the wind. It gets easier, it gets performance. So you can leave it. So we had the idea which could turn all around, and with the wind it turns by the other side and come it back again, or something like that. And we had the problem about putting some kind of weight to fix it in some place that we had to fix it with 3 water bottles so it could stay in its place and work fine. So, and at the second day, we had the liberty, the freedom to cut the bottle and explore it by 8 pieces. for example, making the PET bottle strips, where we were cutting with blades and make the long strips for about 5 or 6 meters, something 6 meters, something like that. And we had the idea of melt the plastic bottles in the ovens. So with that idea, we collected a lot of bottom bottles from the bottle, of course, and we started by just melting them. And after that, somebody had the idea of pressing it in the middle of 2 steel plates, where we put it in the middle of 2 steel plates, let it in the oven to melt down, and that gets exact temperature where we can manipulate it, and we put it in the hydraulic presser, where we could turn the bottom bottles into a little plastic plate that we normally have by its original form, it has already a rigid structure. It's really hard to break it or fold it. So we pressed it and it gets more rigider, more stronger, and more difficult to break it. So, and for example, we try to do only bottle rings, cutting the middle of the bottle and putting it in, not pressing it. And by this action, we had the plastic rings were melted down. And the funny thing about it is that every ring that we made of it, it made a different formation, a different form. So this was pretty interesting, but it was something that we couldn't work with because for this purpose, for this reason that it always has a different form, we don't know exactly about his structure. So we just try to make it something with aesthetical idea or something like that. So stay with us, but we're still thinking what to do with them. As I said, we decided to work with the bottom part of the bottle. Take the advantage of the molded bottom strength, and we had the idea of connecting the bottoms with each other, creating some kind of a curtain, a wall made all of those plastics with different colors, different forms, but with a rigid structure. So. And then we have the day we came to FAUUSP. Then we changed it a little bit, our plans, and we started working with cardboards. So, and at the idea of cardboard, at the day we were working with cardboards, as we presented here, we had an idea to create some kind of shelter, a private shelter with all the cardboards, and with it we kind of had possibility to explore its structure for folding it from about 3, 4, 5 parts, or making all around and all those stuff. And for example, it was a different day from the others because it was a different material. But for example, people from FAUUSP liked a lot the idea, liked the day and its work, because they said they kind of enjoyed the idea of creating something that it has a exact purpose on it. So something more to add, or just that? And we at the really relevant thing about the 6th March, about the 3rd day, we started to work more together as a group. So we started to share more our ideas and create a real group. So And at the 7th March, we continued the idea of making a net with the bottom bottles. And we actually, at the first time, we started making it with wires. We had a hinge in the lab where we took some pieces of the wires and put it around of the bottles, but it wasn't too strong to hold everything together. So we had the possibility to use what the plastic strips made out of nylon, or for example, in my opinion, its popular name is Tired Up. So we have known that it can carries around 50 kilos to 150 kilos, something like that, each one. So we put it all together only with Tired Ups. And this is it's a close-up image from the net. And well, and the project conclusion was use the strong part of the bottom, made it stronger. So we actually, the first time we saw the bottles, we thought that it won't work so good. We thought that you might break sometimes or something like that. So for example, if we didn't melt the bottom bottles, if we didn't melt the strips that we made out of PET bottles, its structure, it couldn't be carrying a person. And by melting them, we made it all stronger, we shrink them, and it made what our idea possible to make it real. And another thing that we came out to a conclusion, it was that we can do almost everything with PET bottles. With its original form, with some specific part of it. So, for example, our job was all with the bottoms, with the strips all around, to create, for example, a ring where we can fix in some kind of hook. We made with a boca da garrafa. Mouth bottle? Bottleneck, yeah. With the bottleneck, we kind of pressed it and make all the ring with the plastic strip. So we kind of used the whole bottle to make this swing. And Myrna has the idea to go in the sun and see how it goes with the shadows. So it's kind of beautiful, you know. It don't has just a black shadow. You can see colors on it. So colors for your life. And we tried out. We tested and saw if it really works. We tried with tumbling and it worked. If you guys want to, we can try here right now. We'll put tumbling or Agnes from our group here.
We would like to see it. Yeah, in the middle, front.
Okay.
Is that okay?
Can I? Well,
Yeah.
Can I pull here?
Yes, you can go. Just do it.
Who's coming? Agnes or Tim? Agnes. Come here.
Watch out.
Swing it.
Swing it. No.
So that is.
Thanks for making this workshop possible. It's been a pleasure for us. teaming up, bringing ideas to life, talking about materials. Thanks to everybody involved in this workshop being possible. It's a very good experience for us, at least the Danes coming here to Brazil, learning from your funky methods of exploring materials. It has been equally challenging and interesting and difficult and fun. Most of all, fun. The thing was to have fun. Our point was at no time to make any kind of project, just experiment. Experiment, experiment. Yeah.
Yes.
Okay.
Yeah, I have to talk with
Day one, plastic bottles. We started, what? Okay, we started trying to connect them at the top. We were drilling holes with this nice Dremel machine, and we took the wire, I don't know, I forgot the material, the wire. We put it together and we made a ring. Okay, but it didn't work. So we took some strips, cat killers, and tied it together. It's a beautiful thing we have here, and it can turn. The funky thing is it's really, really strong down here at the bottom. So it's actually pretty tight, and it's even flexible at the same time as it's strong.
So the movement.
No, the other way. Yes.
Yeah, but it's still, wait a second. There's also, how do you say it in English, Adriano? Like a 5-point synetic joint, is it? Well, I was playing with this like this, just for fun, Oh, like a joystick, something like that.
I have a comment. For you who are watching this video in the future and you think, oh, that's so stupid, playing with plastic bottles, it's freaking hard to play with these bottles. Like, the first time you think is, oh, let's just pinch a hole in it, and then you get a scissor, and you do like that, and you can't. Like, it's really, really hard. So, it looks simple, but we really were trying really complex stuff.
Yeah. So.
Oh yeah, I'm coming back because like Toby is really quick. We started playing with the hard parts of the bottle, like the neck and the bottom. First with the neck, and we saw that if we join all the necks, the bottles automatically they would flip like this and fit one each other, and we could do like this, things like this, the pyramid. Yeah, so we were just experimenting, putting a lot of tension with the copper wire thing. That, like, if we didn't hold the bottles, something like that would happen, because they're so strong. And then we passed on to drilling half the bottles in the top and half the bottles in the bottom, and that's what happened. We saw that the neck fits really nicely on the little bump you have. Yeah. So you can fit exactly 5 bottles in the bottom of one bottle. Yeah. Those are silly words, right? And then we first tried with the wire, but it was really, really hard. So we passed on to the zip thing that in Brazil we call caterpillars. I don't know why. Then that's the result. Yeah, cat hangers. And then we turned it around and we discovered that it does the nice movement. The nice spring movement. Yeah. We tried exploring triangles to see if we could make it static and don't move like harder. We did larger structures, but then we dismounted them to use the bottles. But yeah, it got pretty hard. And we were trying to use only one cord to connect all the bottles. That was first day, first day. And then we, yeah,
we try to experiment other properties of the bottle, so which parts float, what's the density, and the cap floats, the pad. So we think that this is probably not pad because, yeah, it floats. And then we were still thinking that this was a silly material, so when we got the strips, we were like, oh, then we can just put them together like this and put them in the oven, and they're gonna like melt and stick together, and then we're gonna have a huge thing that we can make a dress or something. But no, it doesn't. But
we forgot that the vessel was completely cold when we put it in the oven, and the vessel is quite thick, so there was no chance in hell that this would work. But it might have worked if it was in the oven when we started.
Yeah, but Adriano said an important thing. Like, if we have to heat the oven to 3,000 degrees to make it melt, it makes no sense because we are putting too much energy into recycling this material. Then we got the powder and we tried molding, and I think the girls could talk about it because they were really interested in it.
We wanted to explore another way to use these materials, so we decided to use the grains to melt it, and then we talked to Adriano, and he gave us the idea to create a specific mold to, I don't know, just to explore. And then he gave us like 10 minutes to think about something, and then we decided to create a mold that could be similar to blocks, but they could be joined somehow. So we thought about Lego too, like the other group, and then we changed it, and we have like these little pieces, and they're not. The first idea was to create something that was like similar to a square here, but then we found out that it was not possible because the CNC machine made like round things, so it was not possible to do this. And then, well, we create these little pieces, and they fit not perfectly, of course, because they're round, but and we also tested these pieces, and we found out that they can take like around 8 tons of weight on it. I think they can handle more, but it was just me and Catherine trying to put the weight, so we were not so strong, so the maximum was like almost 8 tons. And we also found out that one piece of these has around 25 grams, and then similar to half a bottle. And we were thinking about making, of course, in the future, some kind of bricks, I don't know, maybe to build a house or things like this, or also working with tiles to, I don't know, use roofs or something like this, because it's a strong material, and I think melting is a good way to work with it, and it has a good appearance too, sometimes.
The powder stuff and putting on the mold, and then taking the mold out. Yeah, talk a little. You like to talk.
I like to talk, but I don't like to say goodbye. If it was in the beginning, it would be easier. This is the result. I think we could use the bricks to nail something on the wall, because it can work as the plastic. I don't know the name of busha in English. You might know, Adriano. Like when we use nylon for protection or for compression.
Plastic nets.
Plastic net. Like a screw nut. So maybe this material can take compression a little and can be used to fix better some metal on the wall maybe or something on this way. Let's go. Next. This is you.
We were thinking about a way, like, because you can't melt the plastic, the lasses plastic to make them stick it together. We tried to think another way to put them together and make like maybe a hole or maybe another extractor more stronger. And then we start to doing like a circle in a bigger size just to see how it is. And then maybe it was smaller to make a hole. And then we did a circle and with nails and turn it around and press it. And then we put the heat, and then it had this extractor that's kind of finer. It's thinner than the other one that we did with the machine. And it's like hard, and it's like, I think it's a good draw and shape, but I don't know how to use it. And then we think about to make like a kind of a basket, and it was like this, but it was not so strong because it's not exactly
it was not great.
It's great enough. And then we also tried it in another way and melted again, and it was like going like this. And we think that if we had something to go inside here, just to
keep the shape.
Keep the shape, then make it would be like a igloo or this kind of structure. And I think it would be like working more on it and get a good result.
Well, I want to talk about it. We took a break because first Toby left her group because he didn't want to work with us, so we got angry at him, and then everybody started leaving, and then we took a break at FAU, but the next day was awesome. So,
we just now it was a good hook about talking about keeping the form, all right? Because in maybe yesterday I was a little tired about heating and melting, and I thought this was too much energy expend. We should find solutions that are closer to us, maybe, or maybe closer to a structure, not an industrial structure, but I don't know, maybe when I heard about the guy from FAU who went to visit us and works with PET, not in São Paulo, but in Vale do Paraíba, am I right? Vale do Paraíba? Okay, so I was thinking a lot about this guy too, and how we can we could use PET without having to transport it to industrial facilities. Okay, not to spend twice the energy to go and to come back with the garbage, right? So I started playing like I play with the glasses, the disposable glasses. I've learned this when I was very young. It is possible to cut them and then to twist them around and give like almost a braid shape all the way outside. Okay, and then I thought about maybe giving some order or putting them in order, the first and the last, and maybe all the others in the middle, 1, 2, 3, and then we got this structure here. It is called for us the onion. It has this mechanic property. It keeps the shape of the bottle in a way, and it uses only cutting to rebuild or retransfer this energy, this first energy. This is almost all analogically. It is. After the bottle is waste, it is transformed to be something else, something useful maybe in the future.
Yeah, and And it's important to notice in the process that we started with a spring motion with this weird thing here, which is kind of similar to the motion we got here. So it kind of makes sense. We didn't know, but in the end it made sense.
Yeah. Then we created the trampoline. We thought a lot about what we're going to do with this. Are we going to try to make it better and the best possible, one unit, or are we going to spend a little more time trying to make more than one unit so people could see the use or maybe have fun, as you'll see in the future. Giorgio gives us the idea to try to make it the best possible one unit. So we can present you the best possible unit and then imagine how we could use. But maybe we were a little tired of working or thinking on this onion, so we went for the 4 onions like this. We tested it, not in the high-tech machine, but with the weight machine. What is this called? Balança? Scale, perfect. So we tried with the scale. It weighs maybe 25 grams because of the rubber band too, and it can be pushed until 700 or 800 grams until it starts collapsing. I think it might be good. I wouldn't know what to say until we tried making this with larger stripes and turning it the other way around. Okay, so this is not in the same sense. Here we have the cap exposed, and here we have the cap protected. This can take until the course of this is a little shorter, but it can take 1 kilo. It's a little more. So maybe the bottle structure too was different. It's difficult to compare, but still they have more or less the same function, or maybe the same ability. The function will come when we find. This is the ability they have. Like we have the ability to write, but we are not all writers. That's about the bottles. The final and the result is. Oh, is this one the result? Okay, I forgot. We had no picture of this. But you have a very nice video that I wanted to show you. Wait, this is the video about the trampoline. Trust me, man. It's going to be alright. Yeah. I might play it maybe 4 times, 400 grams. It's funny. You can. Who wants to buy it? We're gonna try to sell it. It's patent required. Yeah, we have you right. That's it. We could not be finished before one last special. Yeah, go for it. Happy birthday, Artur.
With the last group, and I think we will try to make it a little short. I think everybody's melting here, and then we always gone over time, so we'll do our best. We started by talking about the balls and talking about joining and how to join them to make a strong structure that you could also kind of make loosen up again. So we put a wire through the 2 bubbles and made some nuts at the end. And when you kind of open the bubbles, you you stretch the wire and then you kind of make a hard construction. We did it in both ways, and it kind of works, but the bottle gets tired and the wire gets stretched too much when you work it too much. We had a lot of talking about joining bottles in different ways and kind of just make different kinds of shapes and put them together, kind of Lego style as well, but that was not our intention. We started with the wire again, but we turned over to just use plastic. We talked a lot about just using the bottle and nothing more. When we used the hot strings, we also discovered that it kind of ruined the bottles the more that you work it. And
this form has flexibility. We can change the form that we can fix them in each other and create huge structures with it. And at the first steps we made, it just only had one female. It was one female and one male. So this way is something double, so you can put more and more and more, and it grows it anywhere. And it's one of the forms that you can get. So you can have something vertical, horizontal, or three-dimensional. Like this beauty scarf too.
It's a lot flexible.
Yeah, it's really flexible, and there's another structures there that we can use.
yeah, we had a lot of problems with kind of making the nuts, so we were talking about doing something that you can bind the thread with, and so it wouldn't be too difficult to connect the bottles. So we had different types of ways to do it. And then we kind of wanted to put them together in another way. We made a small clip. And it was kind of, it's a little, it's not that strong that we hoped, and but it's very flexible. And we had a long discussion about making that clip in different ways, and cutting and clipping, and then just today we discovered that we actually have a connection just in front of us. We just have to saw the top of the bottle, and then we could connect it easy and turn the bottle around. So that was a kind of an aha experience.
Yeah.
Yeah, well, we just decided to build a frame, so we had a starting point, and so we could, kind of turn some of the bottles and just build them together as a kind of structure and see what happens, and the strings and all the stuff. But yeah, it's just experimenting, testing, and had a lot of fun.
Okay then. So we just figured out that it would be way interesting discovering and really exploring the material. So as what was given to us was not only the material, but it was in the turned shape. We decided that maybe it would be smarter if you take advantage of that and advantage of the properties of also like the material. So we just discovered that when you hit pad, it's just really unpredictable, and you can't really control it.
So we just started to figure it out, a way that you can take advantage of the shrinking property of the pad. So we just starting like in this kind of thinking, the connections and making the bottles together, but in a way that you can change it or you can just have this modular thinking. We are trying to make some connections. And what we figured out, okay, and then we just discovered a way that you can put a heater and you can melt and start like grabbing the other cap, but not damaging the other parts that we thought that it was important. So what we thought was that in this kind of technique, with water, you can have way more control of the melting process. So here we have a video. Proper position, I'm so sorry for that. But we just start like melting it, and then it just kind of bends on the level of the water. So it's just pretty interesting thing. Well, so with that kind of technique, we can make really different and I think interesting shapes, like this one that Christian just did. So with like, you just put water over here and then you heat it and then you pour more water and then you create like this kind of different shapes. But also with the idea of the connections, we just started to figure out a way to make it more interesting. So we just thought about having 3. And then it is not glued, it just with heat and pad. And the resistance of this, we just have to figure out a way to make it stronger, because when you start to twist the bottles, it's not that strong. But we just, we were proud that we could make this thing to just be structured, because it was really hard to put the caps together and make it in the right position.
Well, this is the group's focus helmet. So when you're out of focus, you can kind of just put it on and take a few minutes. And yeah, it was just the kind of made out of leftovers from other experience.
It actually works.
We learned how to make strings with out of the plastic bottles with the special tools, and then we make some. We made some experiments with the strings. This one is a wood frame where we attach it with nails and waving a pattern over under, and we will try to see what it would be like if we was heating it with the heat blower, because the point was we thought it maybe stick together and be one surface, but it didn't. So yeah, but it was fun to try it.
Yeah, I think we don't have the for the. Yeah, we don't have the photo, but I tried to make like some bricks with the modules that we made. Like in a construction site, you can make like a wall with it, like this one, and control the angles. Make some angled wall and fill it with concrete. And as it is hollow, I think it has almost the same structure as the solid one. And you spend less concrete, and you can build things, I think, a little bit faster than the other way. And you can like start building other ones, and just pouring concrete. It's not the best one, it's concrete. didn't draw it so well. I think it could work. And we had a lot of ideas, but we don't like make a real product. We just try to figure out how to work with the material. And I think we got a lot of different ways to do it.
Yeah, sorry, I wanted to be like really short, but just like as a conclusion, I think we just discovered a way that we feel comfortable of not showing you a real product, like a final product, and just we feel really comfortable on just giving you a bunch of good ideas and really respecting the material and trying really to understand it. And sometimes it takes time, and sometimes you just get frustrated because it doesn't do what you want. But then we just start to figure it out a way to see what the material wants to give you. So then I think it would what we concluded. I think.
Something happened. I think the problem was Joachim got an idea. He wanted to make a chair. We wanted to try what we could use these strings from the bottles to. We had the bamboo from the rest of the wood bamboo floor. I think maybe it's like here, so it must be that. It's really strong, so we made this these two thin frames, drilled some holes, and flatted it. I don't know what's flatted called. Flatted? Yeah, okay. Yeah, okay. And Giorgi, I think you should talk about your idea.
It was not the idea was to see the strength in this string. To see if we could build anything that could hold the human body in a way. So the idea is it's a beach chair you can fold and take to the beach or to the park or picnic, whatever. And when and when you have been in the ocean and swim and your towel is wet and
it's
your
a sexy
pants is wet, you can put your stuff and then it's become a purse. A man's purse. It's good stuff. But the whole idea was just to see what you could do with the strings. Actually about waving it.
The idea at first was these should have been a little bit thinner, so they could easily go out here, and then these could be the
carry it on your shoulder.
Yeah, it would be a little bit more sexy, I think.
Yeah, I think so.
But it works.
But it works. It's actually quite nice because I've used it 2 days today because we were waiting on the bus. Just it's not so comfortable.
It's not.
15 minutes, your back is hurting.
That might be because this is pretty straight.
Yeah,
and it's
around.
It goes direct through your spine, so it's it could be more comfy, but we didn't have the time to bend the bamboo.
In 13 minutes, it's comfortable.
Yeah. And it has been tested. I think from it's been tested and it holds.
Yeah.
And I'm probably the heaviest guy.
I'm actually amazed how strong this is. It's a nice way because I've never thought to make a chair out of plastic bottles before. So I think it was fun to try.